check for stereochemistry for me?
Now, from last week, there was a reaction called hydroxylation.
Yes.
This hydroxylation is a syn addition. Okay? And it is used, what do we use?
OH.
What do we use? Osmonium.
Oh, yeah. O4.
This is the O5O4, yes? As I remember. That's an S?
What was this called again?
O5OS.
OSO4. Is this syn diol?
That's
Yeah.
And what else was here?
NH3.
Okay, so this is going to give you syn addition. And what this is going to give you, it will be diol. This will be cis diols. That's what it's going to give you. And a diol,
Is it OH?
two OHs.
Yep.
So the product of this will be,
You said it.
Yeah, of course.
product of this would be one OH here and the other OH on
The same.
the same side.
Why do you have to put the cis in front of diol? Because it's a syn? But you don't do that with anything else that's syn addition?
I don't know, I did it without. So that gives you a cis diol. Is there a way that we can get a trans diol? Yeah, there is. No, but you can't switch them without reaction.
obviously.
And sometimes all options are not available, but yes, there is a way to do it, and the way is by, so you have a double bond, and you treat this double bond with something called metachloropropbenzoic acid,
Yeah.
MCPBA.
Mm-hmm.
An MCPBA,
Metachlor benzoic acid.
that's that. That's MCPBA. It's a peroxy acid. So metachloroporoxybenzoic acid. So benzoic acid will be up to here, but it's a peroxide. That's why it says peroxide. Okay? What this is going to do is undergo an oxidation. So MCPBA is oxidized. And it's going to make an epoxide from here. This is an alkene. And this is an epoxide. You ever heard of epoxides before?
Yeah.
Outstanding. And obviously the epoxide will be on the same side because it's this triangular, it's on the same side. So you can put in both dash or both wedges or whatever you want. Now that epoxide can undergo ring opening. Is this reaction here? This is the reaction on the second page. So you circle down because we might not have all of them. But. So the first one is G, yes? This one is G. Okay? And following G, we go to 2. You see it?
Yeah. With the HCl plus.
And on 2, what do we have? We have an epoxide, which we made from G. And with this epoxide, H3O plus water is going to be the one attacked. this will be protonated. And because this is in this ring, have you noticed that the rings always get attacked on the opposite side?
Yeah.
Have you noticed or not? So this triple looks like what? What does this look like?
Oxidation ion.
It looks like bromonium, chlorinium, or mercurium,
Oxonium.
yes?
Right.
It will attack on the other side, and every time it gets attacked on the other side, it will give you anti.
Anti.
Okay, there's the reason why this is anti. So all you are going to do is, you are going to redraw this thing, and if one OH goes here, the other OH is where?
At the back.
The dash.
Here. If you write the OH here, the other OH will
The
Yeah,
way.
the
Go here.
wedge.
So on the test, if I ask you to give me a reaction to make a cis diol, what do you choose? Osmonium tetroxide and
Tetroxide.
sodium bisulfite.
Okay.
Yes? And if I ask you for a trans,
Metachlor perbenzoic
you
acid.
use in the first step MCPBA and in the second step H3O. Okay? And what is that going to do? It is going to do ring opening.
Thank God for this video.
Transdiol, right?
Huh?
That's transdiol.
Transdiol, yes. This was in addition, this is called, I wrote cis diol here, yes?
Yep.
This says diol. This is ¿La viste again? Don't wait, man.
Oh, it's
La
just
viste
that
got issues, man. What is it that they call that problem? Irritable bowel syndrome, yes? It produces methane in excess quantities. All right, we did ozonolysis, yes? Ozonolysis? No?
Yeah, O3. Did we do that one? We did one?
Yeah, you put a line.
Or we just drew it?
Ozonolysis?
Oh, no, that was nothing to do with
Ozonolysis is when you treat a double bond with ozone,
Yeah.
and what this does is it breaks the bond. Some people add the zinc and the H+, and some other people add something else. What is it? DMS, which is dimethyl sulfide, yes? It looks like this. Either this or this. You remember whichever one. This is called DMS. And what this does is bond cleavage. Look how simple this is. You see where that double bond is?
Yeah.
You just put
You are going to put an oxygen on one,
and another
And
oxygen.
another one.
the oxygen in the other.
Uh-huh.
So if these were carbons, you would get ketones.
Right.
Yeah.
Okay?
Mm-hmm.
If they were not carbons and one of them was a hydrogen, then you will get an aldehyde.
Aldehyde.
All right?
Yeah.
So let's do one of those. Hydroboration? What are you talking about?
like that, like all that stuff.
Huh?
That was the only one that had all that stuff attached to it.
Yeah, these people funny.
That's what that dash.
Dimethyl.
Methyl four. That's what oh, orange.
So what's the product? What's the product?
Very good.
What is on top of the?
better because it's always in the back. Some of your classmates are worried about you, man. They're saying that the doctors prescribe antibiotics for that sort of thing. That gives you urgency in urination.
So you said that's or, that's what it says, right?
Yeah.
What's
that OR?
That's or, right? Because it looks like a 12.
Yes, all 12.
It's O12?
Oh, it's 012?
No, it's not O12, it's or.
Oh.
Or what?
It's just funny.
Or what? Like, what are we oring?
If you would have,
Oh,
if you
3.
guys would have paid attention,
Oh my
nobody would
God.
have to repeat this to you.
Ozone.
I was trying to draw like that long.
Because I asked a question and somebody even answered the question.
It wasn't me, I promise.
Of course it wasn't you, but you were not paying attention. That's why you don't understand that it cannot possibly say, oh, 12.
I thought I said or, but I don't know, I don't understand. Just,
Guys, write the answer to the problem I wrote there. You did it
have.
already? You did it? Outstanding. So, guys, be quiet, please. Here's the carbon, double bond to an oxygen. You write what it's here. You write what it's here, and then you come to this one, and you do it again. And then what it's here. Would it confuse you on the test if I, instead of writing this like that, I wrote it like that?
Yeah.
No.
Would it confuse you on the test if I wrote it like this?
No.
yes.
No.
No.
No. It's even better that way.
Yeah.
You just see the keto.
If this confuses you, you're going to be confused.
That's a ketone. It's even better that way. Because you know it's a ketone. So.
My heart's still beating.
Okay, you know what? Potassium permanganate does the same type of reaction if you have 2 carbons here, 2 carbons there. Okay? So let's do another one, yes?
Yeah. Oh, it's easy. It's just a hyperpollution. I told you that was so long. Oh my gosh. Whenever he did it, you know, it kind of makes sense. Just like
There's one, there's two. So why would you write or? Why would you write like one thing?
I guess so.
Oh, I think you know what is this?
No school tomorrow.
yep.
That's an incentive for some people. I'm telling you. That.
Oh, DMS.
Hey, this is
Oh, so like you need that?
So I don't really credit it.
No, I'm asking what that means. Or that? It can be the CN H plus or it can be this.
Hold on. Let me perfect this.
So this is not gonna add. Okay, that's one is gonna add to those hydrogens.
Yeah.
Yeah, but the front one is not gonna add to any hydrogen. We go to one. We got this. Oh my gosh, this is so amazing.
So does the bottom only have one possibility?
Yeah, because see that KMnO4 is going to
Exactly.
give you OH.
Yeah, it's gonna
Yeah.
give you. You're gonna add oxides into the hydrogen.
Hydrogens,
Yeah.
right.
Just ask. You haven't asked any questions?
But the first one, you're not gonna add anything.
No,
Yeah,
not
you're
with
just
the
gonna
O3.
break it.
Yeah,
Exactly.
right.
You haven't asked any questions. He hasn't asked. Well, done, because students are getting started.
So this is going to add oxygens to that. Okay. Just coloring 1, 2, 3, 4. Here. Yeah, that's it.
Hey guys, you finished?
Yeah, see?
It's taking so long.
See?
Stop talking so you can write. You weren't talking.
I think it's here. Okay. This the hydrogen liquid, the O is going to be added to hydrogen at the top because you have the metal. That's the metal. And the hydrogen is going to be the one at
The bottom. Yeah.
this one.
Yeah.
Yeah, the bottom, right? Yeah. That was right before.
Let me try this.
I don't know. I did a good job. I did a good job. Good job.
You're a beast.
La beast.
Okay. What does this do?
We're gonna break it back
Redraw without the double bond.
with the double bond
You gotta have
oxygen in
the
between.
yeah, oxygen in between.
Break the double one? Yeah, you break the double bond.
And oxygen in between.
Yes.
Oh, you do that little
Yeah.
Yeah.
fine joints.
Is that it?
Yeah.
Check if that's it or if it's not it.
Yeah, because it's in carbon 1, 2, 3, 4, 5. It's the same thing.
Yeah, it's the same thing.
Yeah. 5,
It's the
6.
same exact.
But Professor, if you like break it in between them and put the oxygen in between, it's still the same thing, right?
It is the same thing,
Okay.
but
Yeah, it's the same thing. It's the same thing. Yeah.
but understand that in real life it doesn't look like it.
Yeah.
Oh, okay.
Okay.
It's gonna look like this.
Okay, let
Okay,
me
what
write
else
that
do you
down.
love?
But
How would
So
it
you
be?
write it like this, but the way you wrote it is okay if you wrote it inside like that.
Can you,
Right?
can you show the way inside that, please?
Huh?
Can you show how we would draw it if we wanted to maintain the oxygen inside? Please.
So, how many carbons? There are 6 carbons in here,
Yes.
right?
Mm-hmm.
7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if this gets cut, the OH is going to go here on the second carbon, so on the second carbon, and on the second carbon from the other side.
All right.
But if you wanted to draw it like this,
Mm-hmm.
you could. You would have to draw them very small, yes?
Yep.
Yeah. Exactly what I did.
Yep.
Which looks funny, yes?
Yeah, it does. It does.
Look very funny. I don't understand why they would just keep it safe in the ring.
Huh?
Why would they keep it safe in the ring if it's broken?
Yeah, if it's broken, it wouldn't have, it would never be like that.
right? Okay.
So that's more realistic on the left.
That's what he said.
No, this is what it is on the left.
It's just
Okay.
like when you-
That is what is not realistic. That is your imagination working hard. Now, how about this one? Again,
Yeah,
bond
it's
cleavage,
broken.
yes?
Yes.
Bond cleavage.
Bond cleavage.
So,
Alright.
what you are going to get is,
Now is it header lifted bond cleavage? I think it is. It's header lifted, right? That's header lifted bond cleavage.
Yeah.
Yeah, right.
how about that? Is that it?
Yeah. But no.
It doesn't matter if we like, sorry, go ahead.
Because we have 4 oxygen.
Huh?
We have 4 oxygen.
So what?
So you're just gonna put the 2? I thought you're gonna like add another oxygen to a hydrogen.
Huh?
I'm just saying, like, you have, like in the first one you have 3 oxygens. Now we have KMnO4 4 oxygens.
So,
So I was thinking you just add just 2 oxygens still.
yeah, how many would you like to add? All
3.
No.
No.
I am not giving you what is left over, yes? I am giving you what is called the organic product, yes? What we want. The rest of the stuff is MnO2, okay? Which doesn't matter if you know or not. That's what matters.
It doesn't matter if we, or it doesn't matter if we don't maintain the orientation.
If it's right, it doesn't matter anything.
A lot of that.
How about this one here?
Okay.
Yeah.
One of them is acetone and the other one is? If the carbon of one of the carbons of the double bond, it has a hydrogen, it will give you
An aldehyde.
Aldehyde.
This is in ozonolysis.
Yes.
If you have a hydrogen with potassium permanganate, does not give you an aldehyde.
No.
Okay? If it has a carbon, what it gives you is a
Carboxylic
carboxylic acid.
acid.
Yeah.
Yeah.
Okay? So
that's
this
why.
on this side, it will give you this and the CH2CH3. And on this side, because it has 2 hydrogens,
Yeah.
it'll give you CO2.
2. Yeah, the
Okay.
terminal. Okay.
That's what I was talking about.
Yeah.
CO2.
Okay. Now I see.
No, I don't understand.
Okay, you write it down, I'm gonna say it again, okay? And then we're gonna go into the alkynes chapter. We're not gonna do carbines. Maybe we should do periodic acid. Yeah, let's do periodic acid.
Sounds stressful.
What about when it's cold?
Are you, we're gonna say it again?
Huh?
Are you repeating the second?
Huh? Remember?
Whenever you guys are finished
When it's
writing that, I'm
cold?
gonna repeat it.
When it's cold?
Yeah. Like when you do it and it's cold, the OH, and it gives you a dial.
Yes, I did.
Oh, okay. Alright, okay.
Okay, if you're doing ozonolysis, and here's a double bond that is cleaved, yes?
Mm-hmm.
This double bond breaks here. If that has a hydrogen, the hydrogen will stay in the product, and you just put a carbonyl there, yes? So if you have a hydrogen, you are going to get an aldehyde for ozonolysis. When you are doing it with potassium permanganate, it's not the same thing. If the carbon has a hydrogen, you are going to get a carboxylic acid, not an aldehyde. But if the carbon has two hydrogens, then you are going to get CO2. So this side of the double bond, after you break it, it breaks. This side will form CO2, while that side with one hydrogen will form carboxylic acid.
You can get CO2 from O3 as well. Yeah.
One is the potassium permanganate, and you have two.
This is a diol.
When it's cold.
Using osmosis, ozone, you get aldehyde.
That is a diol, and you can oxidize a diol with periodic acid to form carbonyls here. It's still bond cleavage that is going to give you this.
I'm so tired.
Guys, you passing around the attendance? Why not? Now, I don't know if I explained this before or not, okay? I'm going to explain it now. If the number of hydrogen increases, guys,
Yes.
if the number of hydrogen increases, it's called a reduction. I'm going to say if the number of hydrogens increases, it's called reduction. If the number of oxygens increase, what is that called?
Oxidation.
Oxidation. Now, the reverse of this is also an oxidation, but not the reverse of this for oxygen, but for hydrogen. If the number of hydrogens decreases, this is called
Oxidation.
still oxidation, and for this, the number of oxygens need to do what?
Decrease.
Decrease. It's still called a reduction. Please memorize this. So, from here to here, was that an oxidation or a reduction?
Oxidation.
Why is this an oxidation?
Hydrogen.
Hydrogen is
Hydrogen.
gone.
Yeah.
Hydrogen is gone, or the number of bonds to oxygen has increased. Okay? So, from here, to here, what is this? Reduction or oxidation?
Oxidation.
This is an oxidation. You have an enzyme in your liver that does this, and it's called aldehyde dehydrogenase.
Oh,
No, what was oxidation?
What is that? Oxidation or reduction?
Reduction.
Oxidation.
Reduction.
Oxidation.
Oxidation. You lost.
Where? Which one? Oh, okay. The last one I wasn't able
It
to.
has the same number of oxygens, yes?
Yeah.
What's that? Oxidation or reduction? Reduction. Well, this means, let's just write it. I wrote oxidation there, I didn't want to write H plus. This means oxidation, yes? Oxidation, oxidation. And in order for you to do an oxidation, what do you need? An oxidizing agent, yes? Potassium permanganate is what?
An oxidizing.
Oxidizing agent. Ozone is a what?
Oxidizing.
Proiodic acid is what? Oxidizing
Oxidizing.
agent. So if you don't know, one day when you are doing a reaction, and it has one of those in it, what do you expect the product to be?
Oxidized.
Oxidized.
Okay, so that's a good guess. Not always, it doesn't always work, but it's a pretty good guess for some of them.
Professor,
Yes.
you just said that ozone was an oxidizing,
What happened?
ozone was an oxidizing agent.
Yeah.
So when you explained it, when we were talking about making CO2, you talked about because it was potassium permanganate. When we split up the double bonds, if one of the carbons has two H's, it becomes carbon dioxide, right? Is the same true for ozone? Even though it's
Ozone is an aldehyde.
oh, it was an aldehyde. Even if
Guys, should we go into the alkynes chapter?
No.
Of
Of
course we will.
and it says
It's too much for
if you're if you're an oxidizing agent, then you're being reduced.
Yes, but why are you thinking about that? I explained what I wanted you to understand. If you use an oxidizing agent, what happens to the organic product? It's oxidized. Don't worry about the rest of the things because it get you confused. Guys, you know which ones I'm going to give you from here, yes? No, the carbines are not here. Carbines are these on the top. This is not, you are not responsible for the carbines. But about everything else is on your test. The carbines is the first two.
Okay.
1 and 2, okay.
The first two on this side
Alright.
will not be on the test.
Yeah.
Now, I am going to give you on the test so you are not confused. I'm going to give you an example, at least one example of each of the reactions we have had in the class. At least. Some reactions I'm going to give you 2 or 3 examples. Some of them with stereochemistry, some without stereochemistry. I'm going to give you at least 2 mechanisms for you to do on the test. Okay? And you can bet money that what's going to be on it.
Hydroboration.
Hydroboration is a tough one. If you see hydroboration on the test, that's because I want to, where is she? What do I want to do?
Be tricky.
Trick everybody in order to fail. Okay? Alright? And you are going to have stuff about hydroboration. Alright, alkynes. We are moving into bigger and better things. It is painful. Alkynes are those that have a
Triple.
triple bond. We already know how to calculate IHDs for these things.
Yeah.
Okay? We already know how to calculate IHDs for these things. Let's do some naming for this thing. So the name of that,
It's 7, right? 1, 2, 3, 4, 5, 6, 7, 8. Why are you counting? 1, 2, 3, 4, 5, 6, 7. Yeah. Well, why are you counting? Why are you counting nothing? Where's nothing? What did that mean? What did that mean? What did that mean?
This 7 carbon.
That's not here. So it's 1 bromo.
So look, how do you count it? No, how do you count the carbons?
1, 2, 3, 4, 5, 6, 7.
And then at the top,
what's the name?
It's 2 bromo.
it's on the first part of your count.
3 bromo hep 2
bromo hep 3
hep 3
You can
2
put
bromo.
3, the bond in the middle, or 3 in front of it before you name it.
Does it matter?
Yeah, doesn't matter. You can say,
Okay, guys, so we
or
are
hep 3 iron. You
what
can
do we
do
go
that.
for first? Longest chain, yes?
Yeah, I can do hep 3 iron, or I can do 3 hep
3, 4, 5, 6, 7.
Yeah.
Yep.
That's 7 carbons long. Where do we start? We start from there, we start from here.
The left side.
We start from the left side because the first substitution gave you the lowest number.
Yeah.
Yes? And of course, we only care about simple stuff, yes?
3.
And this is 1,
2, 3, 4, 5.
No.
5, 6, 7.
You failed the test. I'm not being graded. So, 2 bromo. You have to determine where the triple bond begins.
3.
In the order in which you began. So 3. 2
hep.
bromo. 3
Heptine. You can say hep.
Or hep 3 iron.
heptine.
How do you say it?
You can do
Hep 3 iron.
2 bromo, hep 3 ions.
I
Yeah.
can also say that, okay?
What's more proper?
What of them are my
Doesn't matter.
Can you pronounce it?
I don't like starting in the middle of a word to say.
You want me to pronounce an English word?
That's the new word. Hep 3 iron.
Do I
Yeah,
have an
that's the
English
new,
professor to you?
latest word, the new, the most modern. Yeah. Hep 3 iron.
Heptine. Heptine.
The new nomenclature is hep
That's
3
German,
iron.
yes?
Heptine. Yeah, that's German.
You're German, right? Pronounce them things, it's German.
You know.
Okay, but that's kind of boring, yes?
Yeah.
I mean, let's do one more, but
What's the real stuff?
Mechanism.
Cut to the chase. Let's go straight to home run. Instead of going to first base, second base, third base. Let me see. 1, 2,
oh, by the way, wait. This here is called an internal.
internal, yeah.
Yeah.
Internal alkyne.
Alkyne. Yes, nice.
Because the bond is in the middle.
Because the triple bond is inside. Okay?
When would it
Self-explanatory.
not be inside? Oh, when it's not there. That's turned on.
You guys are creepy. Oh my god.
So write the name of both of them.
Which has the most substitution? So 1, 2, 3.